Today we are going to learn about simplifying radical expressions when we're multiplying and adding. I would like you to evaluate each of these expressions in your calculator and get a decimal, and then make a conclusion based upon the results that you observe. If you do not know how to enter a cube root into your calculator, you should know that you can do that by pressing Math and then choosing option 4 for cube root and then put the numbers in. Press pause on your video, and when you're ready to see the answers, press play again. Here are the answers. As you can see, the values on the top and the bottom are identical. So the conclusion you should have drawn is when you're multiplying two radical expressions, you can multiply the radicands. So the values underneath each radical can be multiplied and put under one single radical. The next thing I would like for you to do is evaluate each of these in your calculator, round to the nearest thousandth. And then I want you to write the first 12 non-zero perfect squares here and the first 6 non-zero perfect cubes here. Press pause on your video, and when you're ready to see the answers, press play again. Here are the answers. Check your work. The reason I had you write out the perfect squares and the perfect cubes is that knowing these is very helpful when you're simplifying radicals. So in order to simplify single radical expressions, the idea is to break the radicand, the number expression inside the radical symbol, into two factors. If the radical is a square root, we want one of the two factors to be a perfect square from the list you made above. If the radical is a cube root, we want one of those two factors to be a perfect cube factor from the list you made above. So we want to simplify these expressions using the method we described above, then use our calculator to find the value of the simplified expression to the nearest thousandth, which should be the same as the value you found above. So just to get you started, I'm going to look at the first problem, and I see that it's the square root of 18. And I know that 18 is 9 times 2, and I chose that because 9 is a perfect square. So this can be now simplified to 3 square root 2. Do the remaining two problems on this page, press pause, and when you're ready for the answer again, press play. Here are the other two answers. So you can see 125 is 25 times 5, where 25 is a perfect square. The square root of 25 is 5, so the 5 comes on the outside. This 5 stays on the inside. 2 times 5 is 10, so it's 10 square root of 5. This one, I need to find a perfect cube that's a multiple of 54. So 27 times 2 is 54, and 27 is a perfect cube. Cube root of 27 is 3. So now I multiply the negative 3 on the outside by 3, and I get negative 9 cube root of 2. Next, I'd like you to simplify each of the following radical expressions. Make sure that when you choose a perfect square factor, it's the largest perfect square factor of the number inside the radical. Of course, if it's a cube root, you want to choose the largest perfect cube. Press pause on your video, and when you're ready for the answers, press play. Here are the answers to all the problems. You'll notice that I rewrote 250 as 125 times 2 because 125 is the perfect cube. Gets me my answer here. And in all of these, I chose either a perfect square or a perfect cube, depending upon which type of radical I was simplifying. The next thing I'd like to do is have you use your calculator to find the value of each of the following expressions. So plug these into your calculator, round to the nearest hundred. Press pause on your video, and when you're ready for the answers, press play. Here are the decimal approximations. So check your work. We're going to use these approximations to discover how we can add radical expressions. The decimal answers that you got on the last page were approximations. What we're going to learn today is a strategy to find the values of these expressions in simplified or exact form. That is, your answers will contain radical expressions themselves. So take a look at each of these, and I'm pretty sure most of you feel comfortable combining like terms. So 3x minus 5x is minus 2x plus 7x is 9x. Next, imagine that I am adding and subtracting dogs. If I have 3 dogs and I take 5 dogs away and then add 7 dogs, 3 minus 5 is negative 2, plus 7 is 9 dogs. Same idea here with radicals. We are just combining like terms. I have 3 square root of 2's. I'm taking 5 square root of 2's away, and I'm adding 7 more. So that would give me 9 square root of 2. Take a minute and plug 9 square root of 2 into your calculator, and you should get the same answer here as you did on the previous page when we were just putting it in as the whole expression. The idea of simplifying radical expressions is to make as many radicals in the expression like terms, if at all possible. So first we're going to simplify each of these radicals separately, and then if I have like terms, we're going to add them together. So I'll do this one with you, and then I will have you do this one next. So square root of 50 can be broken down into 25 times 2 plus 3, and 8 is 4 times 2. So the square root of 25 is 5. So I have 5 root 2 plus the square root of 4 is 2. So 3 times 2 is 6. So that gives me 6 square root of 2. Now these are like terms. They can be added together. 5 square root of 2 plus 6 square root of 2 is 11 square root of 2. Press pause on your video, and when you're ready for the answer, press play again. Here is the answer to that problem. 8 was a factor of 16, that's a perfect cube. 27 is a factor of 54, that's a perfect cube. We simplify and we find that we have like terms. Negative 6 cube root of 2 plus 5 cube root of 2 is negative 3 cube root of 2. If you plug these into your calculators, these are the decimal approximations you will get. And if you compare back to when we put these in our calculator, you will get the exact same things that we did previously. I'd like you to give these problems a try. So press pause on your video, and when you're ready to compare with the answers, press play again. Compare your work to these answers. Press pause if you have to. When you're ready to go on, press play. The following expressions to be simplified involve variables. Remember, yesterday we learned when absolute value symbols were necessary and when they were not. I'd like you to simplify these 4 problems using absolute value signs when necessary. Press pause on the video, and when you're ready to see the answers, press play again. Here are the answers. Take a minute and compare your work to these. And when you're done, look for your assignment online. Have a nice day.